small blocks. We have multiple cloud providers. Yeah, these big ones, Amazon, this Google Cloud, Microsoft, and not only you can combine all these small pieces from one vendor, but you can also combine vendors, and having that, you will get even more and more complex solutions, and somehow you need to test. So basically, testing scope will increase. What is the highlights? There are some numbers on this slide, but more or less, like we have the trend that everyone, or almost everyone, is either already migrated to the cloud, utilizing it, or like on its way and like adopting the cloud. So we'll skip this. Some more statistical data is about like these two big portions, like 41%. These are projects or like businesses who are already kind of moving into the cloud, or like another like big portion of market who is already in the cloud and achieved their targets. But still there is like around 30% of projects or companies who is still thinking or like just planning to be there. So here we are. And why it's important to talk about performance testing in the cloud, because if you just Google like biggest cloud outages, yeah, you will find a lot of stories about how something is failed in the cloud, and it's in most cases it also will be related to some performance related issues, like a lot of clients on Black Friday try to access the site and everything breaks. No one thought about like that cloud will not scale properly, or like it was not tested to this extent. So this is very typical issue, yeah. And let's talk about like during the cloud migration. Yeah, we can see that testing plays a really big role. Like top challenges. This is like again using the ChatGPT. Some topics highlighted about that. A lot of these topics are related to testing, and performance testing is playing a big role here. And all is about like cloud is very flexible. It's consists of many small parts, but the main problem is like how to be cost effective. How you know that if in cloud you need more capacity, you just throw more money on it and it will do the job. You can scale it, but the main problem is to be effective in this. How to spend less money but get the best efficiency, best performance. So this is the main challenges in like not just about using the cloud and all its features, but cleverly designing your product and utilizing the best of the cloud. Yeah, so all these things. Now on this very big slide, this is only to show that we have many stages when you are in transition from the cloud to the from the on-premise to the fully in the cloud. Yeah, there is like cloud ready, cloud optimized, and cloud innovative. And along this path, yeah, you have these different topics like resilience, observability, performance, automation, security, sustainability. All these things also changes and how you design your product, yeah, how you test it, how you deal with it. All these processes also changes, depends on in which stage you are. Do you need to test like something on-premise, just one server, or you're already kind of in some hybrid mode, you have some on-premise and something in the cloud, so then you need to adapt. Or you fully in the virtual machines, yeah, you need to test virtual machines. If you are very, very deep in the cloud, you probably will test some lambdas, some like serverless services, codeless services. So how do we do performance testing in the cloud? Typically, we want to do performance testing of the cloud from the cloud. And in general, the main topics are the same. Like we have to assess what we want to test, we have some scope, we have some environment questions, we have some tooling questions, monitoring, methodology, and all these topics are stays the same, but the content is expanding. Like if previously we had some test tools which fits for testing on premise, we need somehow to use maybe the same tools to test the service in the cloud, or we should also migrate the tools, testing tools to the cloud. So we will test cloud from the cloud. And many old, like major testing tools, they also were available for testing on premise, and now they have this tendency to provide a cloud service, so you can utilize and use your tool from the cloud. So you have cloud testing tools. And shortly, and about the methodology, it's very interesting. Yeah, we have this shift left, shift right. We are more agile, and one important point is that we have like we are not geo-restricted. Your development teams can be from anywhere, because like cloud is everywhere. It's easy to connect via internet and do the job. You don't need to sit in one room and access the same server like that. So geography changed, so you can develop the cloud services from anywhere in very agile way, developing, like deploying every 5 minutes some new versions, and at the same time you need to test all this stuff in like faster, bigger, and from everywhere. And with the cloud testing, we have usually same old scope and same old challenges which we need to resolve. Plus, these challenges are even more intensified because cloud is like different scale. It's kind of very flexible. It consists of more pieces. But this, the main thing is that these all pieces are similar to like what we had on premise. On premise you have some networking, on cloud you have some virtual networking stuff, like more the same thing but virtualized, and a lot of different kinds. You have big choice of this, and if you have usually like a physical server, now you have this virtual machines, like Docker instances, like serverless, this just service as a code in different languages, yeah, whatever, like a lot of different choices, a lot of different pieces, and you have to do the same testing on all levels, but more intensified. And here we see like main cloud testing areas. Yeah, we have performance testing and disaster recovery is two big key points what is important to focus on when you are migrated to the cloud. And that's why we are talking about today about performance testing in the cloud. And how to do this testing. And mostly everything is the same as what we used to do traditionally. Yeah, we need to know what we want to test, what goals we need to design our test, we need to execute our test, we need to do test reports, bring some value. But in the previous speakers, they were talking about like transition from just performance testing to the performance engineering. This is exactly where this cloud testing is important, brings importance of this. You don't need just to test that this performance will be available for us, like this performance level, that we can run 1,000 users or million users. With cloud, it's by default, everything is possible. But for what cost, for what money, with what tools, how to design your system in most effective way. this is the question what we need to answer, and we need to test each solution before we can say like, okay, this works, we will do this way, and we will save like millions on selecting better solution rather than less effective one. So all the points are the same, but these sub-points, yeah, they are intensified. There is more things to consider when you are in the cloud. So scope is really like much bigger than it was before. And this performance testing, and yeah, we have some goals, we have some different areas. There is a big list of everything, yeah, what we can test. In the cloud there is like much more things, much more components, and much more things we want to ensure they are working. So previously you had just one server, physical, you need to test just it as a whole. Yeah? Now you have 100 different small components, they should be integrated, working together, and you need to test everything in all the possible combinations. And you need to be ready to like anything, to an earthquake in one data center, you need to have another data center that will still support your business operation. And here, having this intro, yeah, we will focus more about this resiliency topic. So resiliency is everything about the ability of your system to sustain, prevent the failure, and if failure happens, to recover from failure. And failure can be anything. It can be like hacker attacks, just failures, earthquakes, any physical hardware failure, anything which leads to some problems. And this resiliency is a big topic which can be divided in two main areas. Like one is very, I think it's very understandable. It's availability, yeah, and disaster recovery. So availability, it's all about how we ensure that our system is working fine under different loads, like during peak hours, during Black Fridays. How do we ensure that the system will work without problems? And disaster recovery is like, it's our strategy, our plan, our approach. How do we recover if such problem arises? Yeah? What do we do? How do we recover from the failures? If availability like wasn't enough to make sure that everything works fine, yet something really unexpected happened. Yeah, then we need to have a backup plan how we recover from back to operation, how we get back to operation. And now one step back about like responsibility. When you are in the cloud, you have a cloud provider, and they ensure that you have a good platform, that this platform is scalable. You can virtualize your services. So cloud provider is responsible for the hardware itself, for this compute, storage, database, networking, for the data infrastructure, for these availability zones, for these multi-region locations, yeah, for all these basic things, which is fundamental. But still, it's not a magic, and you should build your solution on top of that, and you are responsible for architecture, for how you use all these cloud pieces, how you build your solution from all these small pieces what is provided by the cloud. And you are fully responsible for effectiveness of using this cloud. Any cloud that you select. You can select multiple clouds and combine in one big solution. Yeah, so, and you are responsible for ensuring that you have like failure-proof solution for the resilience. And this means that you need to test your software product what you build. If you don't test, And I went through this on practice, yeah, in the projects I worked during the transition to the cloud, yeah. Never trust that everything will work out of the box. Yeah, you always need to test your solution. There is million of different ways how you can configure every small piece, how it works, like, and you need to test to have a proof that it will work actually, that it will not fail. And cloud provider in general, they just provide you the possibility to use this scalability, this auto-scaling stuff, these things which help you to be more resilient, but it depends on how you build your product, how you use these possibilities. Your final result will depend on how you test it and how you design your product. Okay? So the main point is about how you design your product and how you then test it. And performance engineering is needed to provide some recommendations back to development. Yet, so this solution doesn't work well. Maybe we can try something else, like another option. And this is where this performance engineering comes. So you are not only just validating that this will work, yeah, but you working together with development, finding better solutions, more effective, and then you do some tests to prove this. And for example, very interesting topic is this disaster prevention and recovery. So, as I said, it's about like how you recover from the failures. And there is like 4 categories of your strategy. Very traditional backup and restore. If something fails, okay, we have like our database failed, we go take, I don't know, like from the tape or from some disk and restore the files back into database. We spend like 1 week for just reconfiguring everything, getting the files from the backup. We have some very old outdated copies, yeah, because we probably have some, like once a week we just backup all the files, yeah. And then if you break in the middle, yeah, you have all the data lost for this current week. So very slow, very ineffective way how to have a disaster recovery strategy. This is like old style. Then there is like such terminology like pilot light, is when you have some small instance which is ready to be quickly brought up, and like if your main servers are failing, yeah, this small instance will be scaled up and can like in some 10-20 minutes be upscaled to the same size, and to take like all the load, all the traffic on itself, yeah. And this is much better than waiting for a couple of days when you buy a new server from the store, install it, and launch it, yeah, from the scratch. So there is like this warm standby approach, when you have basically a copy of your server which is not accepting any traffic, but it's like ready for accepting for the load, yeah. And when failure happens, the traffic just being redirected to that another backup servers, and in few minutes it will be warm and ready for operation, normal operation. Another, the best one is like when you have real-time this disaster recovery. It's like when you're running multiple active servers. Yeah, if one server is down, other servers immediately takes all this extra traffic on top. And yeah, so there is also many good cloud tools which helps you. Yeah, there is like such terms like failover, scaling, spike arrest, circuit breaker, canary builds. So For example, spike arrest is a mechanism which prevents overloading your server when you monitor like what is the current capacity of your service. If there is like more or sudden load like which exceeds your capacity, you don't accept it, you just throw it out, and you don't hurt your server, you don't overload your servers. Yeah, for a while, but after that servers can scale up, and then the spike arrest feature will allow this extra traffic to come into your service, and then everything will fine. So yeah, and one good option like is this canary, but it's more about when you want to deploy some new version, you don't change like immediately to the new version. You just deploy one small instance of your service and let it consume like, for example, 10% of the traffic, and you monitor if it works well. You can then replace all the other servers to the new software. This is how you can kind of ensure that you have trouble-free deployments. And this, all these things are actively being used in the project I work, and this all very new, interesting stuff is really, it takes place, and it helps in making your service more redundant. Yeah, regarding the availability, cloud really has a lot of features. So what availability is, it's basically the time which you can guarantee that service is up, divided by the whole time. Yeah? So if you say like, during a day your service will be down for 1 minute, yes, so then you just divide the 1 day minus 1 minute by 24 hours, you will get this availability equal 99.9995. And cloud itself provides these availability numbers. For example, they say you can use the storage which will be available 99% and 5 nines below the comma. Yes, so you can rely on this, and you can count your availability. You can understand the fundamental like availability of the cloud, and then you can also count on it, and you need to make sure that your service, your solution is not worse than this. What are the options? There is like basically how to ensure availability. You can, for example, calculate what is the biggest load ever possible in your environment, and just bring up so much servers. So at any time, if this like Black Friday happens, you will get all clients will be happy, all the traffic will be served. But why it's not a good idea? Because you will burn a lot of money for nothing. Like all these servers will stay active, and you will pay money for each of the resource, but it will not be utilized. So typically, the availability is supported by like this scaling or auto scaling. It's when your system is automatically adopted by like measuring how much is the demand, how much like request is coming in, how much visitors are using your like, for example, web page, and accordingly resources are being like scaled up. So you pay respectively the money for these resources, yeah, but you don't pay any extra money for any kind of ramped up or like booted up or like server instances. You utilize everything what you have, yeah. And if you need more, you will add more computing power, more DB, according to your needs. And there is like two options, like scaling can be horizontal, when you just add the same resource instances, like multiple of small ones. You can add like more small instances, or you can change the scale. For example, you can increase the database capacity, like what can be done with cloud. With a couple of clicks, you can increase the database capacity, not increasing the count of database working in parallel, but increasing just the database capacity. So two main strategies how you can do this, ensure this availability. And yeah, I will talk a little bit more on the things from the practice. Yeah, one of the most important testing that comes into that we need to do, yeah, when we start migration from like old way from like on-premise or it's to the cloud. Yeah, it's like how we test this scaling ability. Yeah, when you run some predefined number of servers, you know your capacity, and there is nothing to test regarding scalability. Either you have enough resources or not. In cloud, when you migrate to cloud, especially to these Docker containers, to this, for example, maybe lambdas, yeah, you have such cool feature that this auto scaling, yeah, and you need to make sure that if you have more load, yeah, you need to scale more resources. And to test that this scaling works properly, it's not easy to do. It's not easy just to read a topic on this Amazon cloud that like you configure like minimum, maximum instances and just some rules, and it will work out of the box. It will never work as it expected. This scaling can work like with some delay. It may fail to scale. It may fail to downscale. And on this picture, yeah, we have this violet bars. It's like represent the demand, yeah, and this red line is represent our current scale, our current capacity. And the main point of testing and fine-tuning this auto-scaling stuff is to be as closer as possible with this red line to this bar, yeah. So all this gray area is like wasted money because you have some more capacity which is unutilized. So you basically want to spend as much as possible, like less money on doing the same job. So this is like why this auto scaling needs a really good amount of testing, and it's very hard to configure it without testing, because only with testing, with simulating the realistic situations, you will understand if solution works or not. And yeah, more about like scaling modes. There is a lot of different opportunities how you can configure in the cloud. Yeah, usually it can be like manual scaling, like, or you can just monitor what is going on in your cloud, yeah, and manually add some more instances. It will not be effective. You will need to pay for some special DevOps money, yeah. So it's only for some exceptional cases, probably when you need to fix some current issue, when like automation is not working, and you can quickly get rid of the fire. Typically, you want to use the dynamic scaling, and this dynamic scaling has also some subcategories like target tracking scaling, step scaling, simple scaling, even some like this predictive scaling is like with some artificial intelligence. Yeah, when you can let the artificial intelligence to analyze your usage statistics, your consumption statistics, and it will decide when to scale something up or down. Or you can just have very like more simple scaling when you just have some rule Yeah, if rules can be based on, for example, CPU utilization of your service crosses like 50% of utilization, yeah, then you add a couple more servers and then continue monitoring. If you need more capacity, you will see. Like, so based on some resource monitoring, you can build a scaling strategy. So, and the main point here is how do you know, should you add the trigger for like 50% CPU utilization, 60, 70, maybe 90. It's all can be fine-tuned only when you test different solutions, different combinations of configuration, and then you will know the answer. Yeah. So there is some advices what to do in overall, how to test this auto scaling, how to ensure that your service will scale properly. Yeah, some points that you can check, and some common issues like, for example, you did a perfect rules for scaling, but your servers are booting too slow, so they don't scale in time because very like complex code, and these huge containers are not arriving in time, and then you need to reconfigure everything to adapt to this like slowness. And this scaling never happens immediately. Yeah, there is some lag between you understand we need more servers, and these new servers will be scaled up, will be added to the service, and it may be too late because like sometimes you cannot predict if the traffic increase is too fast. Yeah, it may be even not possible to scale and get everything without errors. So auto scaling will not help you for very sudden spikes. Yeah, because it has some inertia. Yeah, you need some time, couple minutes before your new instances, new like containers, new virtual machines will be booted up, and the faster they boot up, the better situation you have. Yeah, all depends on this agility, how fast you can add more resources. So, and typically to add more resources, first of all, you need to detect the problem. It will be some alarms configured. Alarms are configured based on some monitoring statistics. Monitoring statistics itself is captured maybe once per minute, or maybe once per hour, or once per second. Yeah. So for auto scaling, it's better to configure these statistics, which can be which is captured every like second or 10 seconds. In the worst case, like every minute. Then what we have, like if we have alarm which checks the statistics, and these statistics refreshed only once a minute. So if you have a problem, we will know after 1 minute, maybe after 2 minutes, because you can, like it depends on at which exact time you are checking. So lag with 1 minute, just to understand that we have a problem, just to understand that Houston, we have a problem. Then this alarm can be a false alarm. Usually you cannot trust like, okay, one small spike in load, probably you don't need to scale. Well, probably this is something random happened. Yeah, you need to monitor for 2 events in a row to clearly understand that yes, really we have a problem. Like this is not a small pothole on the road, it's just like bridge is broken, you are falling down. You need to get at least couple measurements to understand for sure that right now you need to throw a lot of money and get new server instances deployed. So this lag can be couple minutes. Yeah, and after you raised alarm, yeah, alarm can trigger an auto scaling. Then this auto-scaling, what it means, you need to add more, you need to boot up a couple more servers, a couple more Docker containers. This can take another minute. So now we have 2 minutes for detecting issue, 1 more minute for booting up the server, and what else? We cannot just throw immediately all the extra traffic on this new instance. It should be done with some ramp-up time. You need to give some another minute and slowly add traffic, because you don't want to kill this cold instance which is just booted up, and it will not survive if you just drop whole capacity, the traffic which will eat all the capacity of this instance at once. You cannot throw 1,000 requests at once on the freshly booted instance. You need to do it slowly. And all these variable things, yeah, you need to configure it. Yeah, this how fast you can optimize your server instance image. Yeah, make it more lightweight so it will boot up faster. You can change some parameters. Yeah, and there is a lot of parameters which you can configure on that way, and this all will affect how quickly this auto-scaling will work, and how aggressively you need to configure the rules which will trigger this auto-scaling. And not only scaling up is important, scaling down is also important. So when you have no demand, you can reduce the cost of services by removing extra instances which are not used. So the very first test, what is usually you want to do is to measure the capacity of one particular server instance. Why it's needed? It's needed to predict how many instances you need to serve this 1,000 requests per second. Or you need to know capacity of one instance to understand how to calculate how many instances you will need for a particular amount of load. And this very first test, what usually is done, when you try to test a very fresh new service, you need to find a breaking point, yeah, and you just increase the load gradually, and you find where the service will stop working in a predictable manner. Yeah. So on this, do we have the laser? Yeah. On these graphs, yeah, you see this red line is so in the beginning, yeah, we have everything predictable. We are adding load. This blue line shows the requests per second. So we are increasing the load, and CPU utilization also predictably increasing. Response time stays stable, yeah. And after some point, we can see that we have some maximum requests. After this point, you cannot get more load served by this instance. Yeah, this is absolutely good breakpoint. But you can see that CPU starts shaking here, and we can see first signs when response time is start to slow down. So we want to use this service only in this range from 0 FPS here, yeah, till for example, 30 FPS, around 30 FPS here. So we don't want to put more load on this particular one instance. So we need to know this range where the service works in a predictable manner. Otherwise, you cannot count on it. What will happen if you apply more load? Service probably will just stop working. It will fail. You will get some errors. It will be slow. So it will be unpredictable. And when you tested one instance, then you are ready to deploy some rules how these multiple instances will work together, and you are ready to configure this auto-scaling. So then, what is our ideal goal? So the blue line shows here the actual demand. So during the day we have some peak hours, maybe 2 peaks during the day, yeah. What you want to do, you want to fine-tune your cloud, so the amount of resources deployed at each moment, yeah, it's as much as possible close, but above the current demand. So then you will have a perfectly predictable response time, perfectly predictable performance, yeah, and you will make sure that everything works fine. But this is ideal situation. In reality, you do your first test, and you see that like scaling up happens like with some delay, and then for half of the other day, the scaling down is not in time. Yeah, so basically you burn a lot of money here because you have too much resources, but it's too late. Like people, your end users, they go to sleep, but your servers are still waiting for some huge load. And here, when this spike happens, you miss. You didn't deploy in time. Your like auto scaling have some lag. Yeah, and yeah, this is like very bad timing. Next time you do some fine tuning, and don't hope it will work well in the second time. You forget to configure downscaling. You scale more or less well, but then after weeks, maybe someone takes a look to the dashboard with like, what is your monthly bill for the resources, and you realize why we are burning so much money. Yeah, it's very good and very important statistics in the cloud when they have the dashboard, like how much money and what is the approximately cost of the environment. And this situation, you can deploy your service, and eventually somewhere after a month just realize that you burned all this money. If you don't check your statistics, yeah, monitoring is very important in the cloud. You need to see what is going on, and just by monitoring, you don't do any tests, just by monitoring, you already can find many problems, many issues, and fix them. And issues like that, when you're burning money for nothing, yeah, by this example, it's clearly visible that we don't downscale our resources. We only go up, up, up. We don't downscale. We need, and more to that, we missed this spike here. Even like we burned so much money, but we missed this small sudden spike here, and there was some problems on this day. Another better example is like, okay, we configured some downscaling, but it's still too slow. And yeah, there could be two options. Like you can do very fast downscaling, so it's start to scale down too early. It's even worse if you still have a huge load and downscaling rules suddenly decide to decrease the amount of resources. You immediately will get another alarm which says, no, we need to upscale. And you will get the system which is shaking up and down all the time. And you will not understand what is happening. Are we scaling up or scaling down? And all the time system will be unstable. So it's better like this situation when scaling down is slower, but at least it's predictable. Yeah. Usually, from my practice, yeah, it works to do very rapid scaling up and then kind of 2-3 times slower scaling down. So after a couple of minutes, you can realize, okay, we don't need so much resources, and you can gradually scale down. But don't do too fast scale down, and like for scaling up, we need usually more rapid reaction. For scaling down, you will burn a little bit more money, but it will be safe for the business. Like users will not be unhappy. Only business will be unhappy with like having too much money. And then business will ask. Traditionally, we had like these physical servers. They was cost us, the cost was like this one, and now this modern auto scaling, downscaling, we don't see big difference. You don't see big difference because you didn't fine tune and you didn't created the good implementation where you really have the most effective and you have cost savings. Yeah, because of these blank gaps. Yeah, if you don't remove these blank gaps, you will burn more money, and sometimes it will be more than like old traditional way, just having 3 servers under the table which are working fine. Yeah, another. This is another bit better one. Yeah, but it's still low efficiency. And last, which we can say test passed, yeah, and this is the picture what you can get in reality. And who knows why we don't have the picture what was here. Like the line is exactly following our demand. Why we have these steps? This. Who has ideas?
Checking performance.
Huh?
Delay of checking performance.
No, it's not delay. It's because you always have some like 1 server, 2 server, 10 servers, and each server has some capacity. For example, one server can add 100 more requests per second capacity. So it's about granularity. If you have like million of very, very small server instances, then you can get very kind of smooth line. But usually you have like 1, 2, 3, 5, 10 servers, and you have 10 like steps. So that's how it works. If you have some, in this case we have like containers, yeah, like small containers. In like in off-peak hours you can have 1 container. In the peak hours you may need 10 containers. So you have 10 steps, like from 1 till 10 containers. You cannot have half container deployed. You will still have to deploy 1 container and pay money for 1 additional container. And here is the question, like sometimes you have option to have few bigger containers or much more like smaller containers. Again, this needs to be tested, yeah, in reality how it works, and you need to calculate. You can do 2 tests, like with smaller containers, but the containers count as bigger, or with bigger containers, but the containers count as smaller. And then you need to calculate the cost of this operation. You need to test like your typical daily profile, and then you can understand this or this solution will be more cost effective. But usually for this resilience needs, yeah, it's better to have at least 3 containers. So if 1 container suddenly kind of crashes, there is 2 another containers which will still serve the traffic, and while this container is being rebooted, yeah, you have 2 other containers which serve it. So it's a bad idea to run just 1 container or 1 big container which can fail at some point, and you will get completely like traffic break during this recovery period. So the minimum size is like 3, maybe 4, 5. It's okay, yeah. And then you can rely on that. If something fails, one particular compute instance fails, other instances will still serve. Yeah, and now a couple more slides. Like this slide is about that performance. Whatever you do, like whatever you do, whatever type of migration to cloud you do, yeah, there is like this typical 5 different options how you can migrate to cloud. Performance and resilience questions will stay very, very important. So at any point of time when you change something, when you migrate someone, there is always a question like, will it work? Will it be available? Will it be reliable? Yeah, and at any doing any change, it works to assess your performance and test this. How this can be done? This is not very interesting slide. It's about that performance testing can be done as a service, or it can be done with dedicated team. And as we all in the cloud, like the way of working is more agile. Yeah? You can, you don't need to set up, like you don't need a performance tester to drive to the like laboratory with into server room and test it. Usually it happens from the cloud. Yeah, you can connect two clouds together, like performance test from the cloud to your service, and it can be tested. And so we have more agility in this way, how you can work like this. And that's it. I hope it was not very boring. And I'm ready for questions. Yes.
Can you return back to the slide with the green line and fancy auto scaling?
Yeah.
Yes, about this. Is the green line the actual auto scaling pattern, or is it just manually drawn as a good example?
So on one graph, technically it's possible, yeah, but usually you have like number of the graph which represents your number of instances, yeah. You don't have the graph like your capacity. Usually we check like the number of instances, and we can put this graph together.
But, is it the actual realistic scenario?
Yes, yes,
Okay.
yes. It's. If I go to our monitoring system, I can show you the same graph, like exactly. Actually, this blue line is like from the reality, yeah, and this is also.
How do you ensure the spike prediction? And well, I'm quite interested in the last one, specifically when the load is actually dropping, yet still we ensure the scaling.
Yeah. This one may be like not true. This is ideal one. Yeah. If you add this artificial intelligence with this predictive scaling, and if like every Wednesday you have this spike, this predictive scaling may instruct you that at this time you will have this more demand, and you need to scale. So in the cloud there is like interesting more options. I haven't yet touched this area. We spent quite a lot of time just for configuring this basic so auto scaling based on CPU, for example. Auto scaling based on this incoming request. So based on CPU works better. Okay. So yeah.
I have two more questions. One is, you already mentioned that auto scaling based on CPU, but how do we handle situations with CPU heavy processes which might be triggered compared to, well, lots of small requests which are not really CPU heavy, and spikes happening from single operation, which probably are single node focused and are not really scaled across the whole infrastructure. So are there options of configuring CPU plus request count or some composite metrics? And how do you actually achieve?
Everything is possible, but it will be hard to test actually. The more kind of variables you bring into the formula, the more complexity of testing. You need to test more combinations.
Well, yeah, but you actually mostly talked about how to actually configure that. So I'm more wondering about how to configure that. Testing that is really easy. You just do the testing with either multiple requests or single requests triggering complex operations. I'm wondering how to configure that. Because I would actually
it depends on the cloud. They have like a lot of kind of how to trigger auto scaling. Yeah, there is like this. You configure the alarm which which will trigger the auto scaling, and there is like some predefined scaling strategies. Yeah, so you can say like we will trigger some adding couple more instances, or adding like maybe plus 50% of instances. Yeah, there is different options how much resources you want that and when. When is like you can select based on CPU, based on requests, some mixed, some artificial intelligence. It depends on a particular cloud. Yeah, I'm more familiar with this AWS cloud. Yeah, there is a lot of options. I didn't even explore like all the possibilities. Yeah, we focused on one basic thing, yeah, and we fine-tuned it. It works well. For some sudden spikes, yeah, there is additional mechanism how to avoid the spike. First of all, you need to prevent the spike. It's like this spike arrest feature can help you. So you don't let these sudden spikes to break your service. You just cut off a bit of extra.
Spike arrest is basically denial of service
Yeah,
to the client.
yeah. But you cut off couple, maybe like hackers are attacking you right now. Yeah, you cut off like some small portion of this traffic to keep all the other people, like all the other service healthy. And when you have this denial of service, yeah, immediately you trigger the scaling, so instances will be added, and when service is ready to accept this extra traffic, yeah, this spike arrest feature will let the traffic in. So you just say, hold on, we are like very busy, we will add more capacity, and then we will open the doors and this traffic come in. It's a mechanism how to prevent the total failure of all the services, because if you overload all the services, yeah, everyone will be affected. And only this small portion of users which causes this sudden spike, yeah, either you block them, either all users are blocked. Yeah, so this is a good option. And yeah, in any case, so this auto scaling is quite slow. It's like minutes, 5 to 10 minutes, yeah, process. You cannot predict like very sudden spikes. For these very sudden spikes, you need to be ready. Okay, if you have very sudden spike, some server instance can die. You need to kind of have the mechanism which checks if this server is alive. If not alive, we are booting up a couple more. Yeah, and still, it's very hard to. So what the problem is? Yeah, to boot up a new server, it takes time. It takes, for example, 3 minutes, and sudden spike happens like during milliseconds. So either you boot up server before this spike happens, before even you know that this spike will happen, and you will, it will be like a lottery. Either spike will happen or not, but you already booted up resource. And this auto scaling is usually like a reactive. It's not predictive. Yeah, we see the increasing demand, and we react on it by adding more resource. If you need to cover these spikes, you need to be predictive, and Amazon Cloud has this artificial intelligence with this predictive scaling. So this predictive scaling can help. But it's if the spike is very sudden and very unpredictable, so you have no choice. You need either cut off and do this denial of service for this spike, yeah. Either you need to let it in and kind of experience some temporary slowness, temporary like issues until your reactive auto scaling will take an action. Yeah.
So you are talking more about AWS, but have you tested, compared also other clouds with AWS?
On practice, just with AWS, and I think each cloud has its very own kind of settings. Concept is similar, yeah, but if you just want to take the same approach, like same settings, what you tested here and they work fine, into another cloud, their rules will be quite different. Like everything will be different, and you need to do. In any case, you need to test again. You don't have the happy formula, like, but approximately what we know, like the steps how scaling happens. First of all, you need to detect the issue, like monitor. It's based on monitoring. Yeah, how fast, how agile is your monitor? What is the granularity? How quickly you get the statistics? What is the lag? Yeah. Then how quickly you raise the alarm? Do you need to monitor for a couple iterations, or you can directly? Yeah. What is actually like the pattern of usage each service like have its own pattern. Somewhere you have very straight line all the way, you don't need any autoscaling, you just know it always will be same. Sometimes you have this daily peak, sometimes you have like this Black Fridays, or once a month you have, I don't know, like this salary payouts when everyone wants to check his salary level, so in bank you see this spike. And so all these factors, you depend on all these small factors. Concept is the same, but whatever you configure, you always have to test, and you have to find and fine-tune these parameters for particular use case, for particular, I don't know, are you using virtual machines in this EC2 instances, in big ones, or you are using containers, or you using some other type of, yeah, it's everything adds some more variativity, yeah, which you need to test, and you need to find exactly this formula works exactly for this case, for this service. And for different services, yeah, we have like 50 different small microservices. For different services, there is also some different approaches. In general, yeah, we have some generic formula already established that this should work for everyone. But for some specific services, yeah, where, for example, this service has like 20 endpoints, but one endpoint is very heavy. If we have one request to this one endpoint, it will be very heavy kick. And you cannot predict on how many requests you get. Yeah, the request can be bigger, smaller, yeah, that's why I say based on CPU it's easier. Yeah, CPU shows the actual kind of load on the service. Also there is option like based on the response time, for example. If time kind of slows down, you can increase resources in hope that it will become faster. But so far, like from my experience, I can tell that you need to deploy at least 3 containers, and then scale based on the CPU. In my case, good trigger is like 50% of CPU. Because you need to have some spare CPU capacity, so this service should survive for a couple more minutes before another service will scale. You need to have some kind of 5 minutes more time that your services will survive under heavy load. And after that, new services will arrive and load will be distributed. So you need to have some capacity, extra capacity in reserve. Yes?
You were talking quite a lot about the cost optimization. I was wondering, this whole presentation and usage patterns are based on the reserved resources within the cloud, or you are basically requesting for scaling from the pools?
So it's all based on this. When you have this auto scaling, it means you add one more, you boot up one more container, one more instance.
Yes, of course.
And you pay more. If you don't boot it, you pay less.
Of course, but if you don't reserve it and therefore pay for it, you can stumble upon issues with lack of available resources within the cloud or within
one good example I have. We tested everything like all scaling well, and then suddenly you realize that you cannot boot more than 300 instances because IP addresses are gone.
Well, that's misconfiguration and incorrect
yeah,
design on your side.
Yes,
that's
yes. It's something that you cannot predict until you test. Yeah, if you have never tested this big scale, there are some surprises can arrive. Yeah,
that is quite a documented feature which is easily predicted by the.
It was not
design.
my fault.
Of course,
I was just
and
testing.
that's not a part of testing. But the question is, you can easily run out of the resources within the cloud or within a specific region, because, well, each type of the resources is still limited within the cloud.
Yeah.
And unless you are actually reserving the resources, you cannot be guaranteed to be served this virtual machine or whatever you are using during the scale-up process. So how do you work around that issue?
So it's not in my visibility, it's about the DevOps. They somehow monitor the overall. We have like million small services, yeah, and the total resource, I don't even know what are the limits. For me, it's like unlimited. I need 1 or 10, like for particular service, yeah, I know that I can have 1 or 20 instances, yeah, they should work within this like big cloud area. In this cloud account, yeah. I don't have visibility all over the all cloud account, like what is the maximum of everything, yeah. It's like we have 40 services, yeah, they have each like up to 10 these containers, and so like 40 by 10, it could be like 400 containers, yeah. I don't follow up to these total numbers, yeah, but for sure someone is setting up and they resolve something.
Maybe from DevOps perspective, I can add that this client wouldn't risk the like unavailability of server, so I don't know how it's configured now as a client, but they definitely choose a better way. And performance tester has the same environment, exactly the same that is on prod. It's the same large machines. They don't economize on this to check the performance.
Yeah, we have very expensive performance environment where we have full control, like we can ramp up many services. We try to not use any extra resources. But yeah, from in the reality, someone needs to predict that you need like more IP addresses. But sometimes it happens like that the human errors happens all the time. It's fully possible. If you never had like this big traffic in the production system, and suddenly this big traffic arrived, anything can happen because it's like unexplored area or untested. And when we test it, we then can confirm that it will work fine. But sometimes you don't want to test some really huge scenarios because the test will cost like more than like months of production cost. So sometimes people are ready to risk, or they just beforehand they check, oh, we will just double all the resource limits by 2 and it will be enough. That's depends on like what is the cheapest, easiest solution for current situation. Yes.
So I suggest we finish. If you have more questions, then you can come directly. Thank you very much.